I recently took a trip to my local IKEA. After sampling the Swedish cuisine, I went looking for my target, the IKEA Lack side table, a perfectly sized table with a perfectly priced tag of $13. I picked up 2 of these. Today I'll be stacking these together and making my dream printer enclosure. You'll find links to all the models used in the description below. The first step was printing out these risers. They were sized to handle the height of the Ender 3 series of printer. I need to make a small pilot hole in each of the 4 feet on the tabletop. I'm not entirely sure what material they make these tables out of, but I don't want to risk cracking them and having to go buy another. I'll attach what I assume is a wood drill bit. I'll be completely honest, I don't know much about drills other than that they spin fast. These legs are mostly hollow, but the bottoms do have about a 1/4 inch of solid material for a screw to bite into. A lot of this video is going to be close-up shots. I don't want to reveal too much until the end. Also, my office is a bit of a mess at the moment, so I need to keep up the cleanliness illusion. These legs will lift the table up about 100 millimeters or so, and have a single hole in the bottom that will be screwed into the leg to extend it. Lining up the screw in the hole is quite a challenge, even more so when the camera is in the way, but I eventually found it. I'll switch over to a Phillips driver and the drill and get to attaching these 4 feet. This would normally be a good time to tell you about the sponsor of today's video, but I couldn't get anybody from IKEA to agree to it. So instead, this is where I'll ask if you go ahead and hit subscribe and keep this channel going. It's truly impressive how much cat fur has already accumulated on the bottom of this table. Everything online tells me that an enclosure will keep the cats out, but to be honest, it seems to be going the other direction for me. Now we can stack this lack that I purchased in a stylish color, black. Hopefully this clip also answers some questions like, no, I don't wear gloves on my feet. Also, working barefoot can help you locate screws you may have dropped. This was looking good. I'm really pleased with how the navy blue material looks against the black table. Because my printer can be a bit violent when printing at higher speeds, I printed some corner brackets that will reinforce the bottom table's legs. Again, linked in the description. These were printed in a beautiful silver PETG. While PLA as a material is more rigid than PETG, it has a tendency to deform under stress over time, whereas PETG will maintain its shape a bit more consistently in the long run. Each corner brace is secured with 6 Phillips screws, 4 into the leg and 2 into the underside of the table. These greatly improve the overall stability and stiffness of the supporting table. I decided not to put these on the top table as it wouldn't be experiencing as much direct force. The risers allow the top table to kind of float on the bottom one. It isn't attached by anything other than gravity and kept in place by the L-shaped brackets on the riser's outer edge. Now all 4 corner brackets were installed and looking good. The next step is lights, and not just any lights. I wanted cob LEDs with color chasing features. I wanted my enclosure to have a bit of life to it, so I chose this 6.5 foot strip, which only costs about $20 on Amazon, or about 1.76 IKEA Lack tables. I measured out my strips and cut them to length. Thankfully, the cut point lined up nearly perfectly with the space between the legs. Now I just had to run some short wires to connect the solder points to one another and keep the LEDs flowing in sequence. Stripping wires this short is really fun, depending on your interpretation of fun. It looks good. I mean, it looks really, really good. I love the different effects built in. It would be fun to program my own, but as I've said in other videos, I'm definitely more of a hardware guy than a programmer. It would be cool if I could get them to turn red during printing and then green when the print is complete, but perhaps I'll leave that for a part 2 video. Now I needed something to power it all. I ordered what may have been the cheapest decently rated power strip on Amazon with a 2-prong plug. You see, my apartment is old. It only has 2-prong outlets. You'd think this would be counterproductive for an electronics guy like myself, but I live life on the edge, a bit ungrounded if you will. This outlet will be great because it supports both USB and standard 3-prong American cables. Unfortunately, in my haste to get power, I forgot to check if this had screw mounting holes on the bottom. It doesn't. So as a temporary solution, I used some double-sided foam tape. This should hold for now. And here's Chris from the future letting you know it did not hold. I'll get those LEDs plugged in and move to the next fun step, the acrylic. Now, I know what you're seeing on screen isn't the acrylic, but there was a bit of a problem. I could get a custom cut single sheet of 3mm thick acrylic, that would fit perfectly for $30. Or I could get a 3-pack of 3mm thick acrylic that is 10mm taller than my opening for $30. So I got the 3-pack and printed 11mm spacers to attach to the risers and lift the top table up enough for the acrylic to clear it. Why buy windows for your house that fit when you could just build your house taller to fit your windows? Big brain moment. I'm using some medium gap filling modeling super glue. This will raise the top table just enough but leave enough lip on the risers to keep it stable on the table. These spacers have a big circle cut out in the center. It isn't really for anything, I just made a hole so it would print faster and use less material. I'm in the home stretches of this project and very ready to see it finished. Now we can move on to the acrylic. The amount of static produced by these protectors might be enough to power my entire printer. My hairs are tingling. Next, I designed and printed these friction fit channels to hold the acrylic between the table legs. They are each secured by 3 screws. They are already the exact height of the space between the tables, so I don't need anything to hold them at the top or bottom. I've also only got 3 panels. I'll have to figure out the front door later. Another thing worth addressing is that the filament holder is too tall to fit in the cabinet I've made, so we'll need to route the filament from the top of the table through it and into the printer. I'll break out my Big Drill Energy, or BDE for short, and punch a hole through the top. Now I can use one of these Bowden tube connectors and screw it in place. This will allow me to run a Bowden through the table and keep it free of wood dust. As a bonus, I can also attach the other end of the Bowden tube to my filament dryer, so I can print directly out of it. Next, I designed and printed a cold shoe mount that can be screwed onto the ceiling of the top table. A cold shoe, as opposed to a hot shoe, is a very standard accessory mount for photography gear. It's mostly used to attach microphones or flashes. I've also got this cold shoe to 1/4 inch screw mount. This will screw directly into the bottom of my USB camera and slide securely into the cold shoe mount I just installed. Finally, it's time to cram my printer into the enclosure. Space is pretty limited and I'm already debating a few cable management changes. You might be wondering why I didn't move the electronics and power supply out of the printer and install it somewhere else, like under the table. This was the original plan, but I went in a different direction for 2 reasons. 1, I couldn't find a decent LCD extension ribbon, and 2, I didn't feel like making one because I was ready to be done and had already decided I'm leaving the front door off and ventilation is just going to be there. And this looks good. I couldn't be happier with how this turned out. My printer is off my computer desk, safely enclosed, and everything runs off of a single power strip that I can use to power it all on or off together. The only things left to do are cable manage a bit better and look into a front door. But for now, I think this is where I'll take a break. I've spent the last 3 weeks working hard on this, and I have a few other projects that need attention. If you've made it this far in the video, thanks. It really helps me out. If you watch my video again, it helps me out twice as much. But you could always just subscribe instead. My goal is to reach 100,000 subscribers by the end of the year, and I'm already 8% to my unachievable goal, so help me out. Thanks for watching. If you want to see more cool projects and guides, check out this playlist I have on 3D printing. You can find links to all the models used in this project on my website, taptic.digital, linked in the description below. I'll see you next time.